is a right triangle, but it could be this one on the left, or it could be this one on the right. It doesn't really matter which one you choose. You just have to choose one that like makes sense to you.
Yeah.
Do either of these stand out to you? Excuse me, as which one you would draw? Like where do you visualize the wall? I guess the wall is, here, or the wall is here.
I envisioned the left side. That's what
The
I
left,
picture.
the left triangle, or the
The left
right
triangle.
left triangle. Okay, so let me clear this other one out. Okay, very good. Okay, so now we have to figure out, well, what is an angle of elevation? The angle of elevation is right there. Okay, and at some point they should have made a drawing for you that said, when you have a triangle, there's two things. There's an angle of elevation and an angle of depression, and they're both the same. They're the same because of the way that parallel lines, when cut by a transversal, end up being the alternate interior angles. So, having said all that, it's a long way of saying you've got this angle of the triangle. They tell you the ladder is 7 feet. They want to know how long, sorry, that they want you to know that the ladder is 7 feet up the wall. They want to know how long is the ladder. You can use X, L, whatever you like here. So sometimes it's good to kind of just, get rid of all the words and all the extra stuff and just say, okay, 64 degrees, 7, and this is X. And you have to decide which trig function are you going to use. Is this sine, cosine, or a tangent problem, and why, maybe more importantly. Is it the sine of 64, the cosine of 64, or the tangent of 64?
See.
That's the whole
I
SOHCAHTOA thing.
It's gonna be sine.
It is sine, and that makes this problem much easier by choosing the right one. Sine 64 degrees equals 7 over X. Okay, now solving for this variable is sometimes frustrating for students. It depends on how you want to get the variable out of the bottom. It's like, how do you see this? Do you see this as, I'm going to multiply both sides by X? Do you see
Yes,
this
that's what I
as,
did.
okay, and that is probably the best choice here. So multiply by X, multiply by X. Okay, so that clears it on the right. X sine 64 equals 7. X equals 7 divided by the sine of 64. Now, a couple of like reasonableness checks. Your mode should be in degrees if you're using a calculator. They're
Right.
asking for the hypotenuse, which is the largest side. So the answer you get should be bigger than 7. Okay, and it is. You end up getting 7.79 feet, something like that. Units are also important. Any questions on how to like enter this in the calculator, or?
No, I'm good on that.
Okay,
That one did come easier to me.
good. All right. New question here. It says a person has a tree that looks like it might fall, so they attach 2 wires from the top of the tree to the ground. One wire is 32 feet long and the other is 40 feet long. The shorter wire has an angle of elevation of 50 degrees. How far apart are the wires at the ground level? So again, you got to draw some sort of a picture here. This one's a little bit more straightforward. I mean, there's the top of the tree going left, going right. Okay. And they are connected at the ground. And we know that one wire is 32 feet and one wire is 40 feet. And if we drop what's called an altitude straight down, it makes 2 right triangles. The shorter wire has an angle of elevation of 50 degrees.
Yeah.
Okay. Now our goal is to find the 2 lengths. Like we'd really like to know, I'll just call this X and Y for the moment. But we may also need to find the height here at some point as well.
Right.
So this is where this is, like you said, this is a much more difficult problem. It's got more going on here. If you are interested in solving for x, you're interested in using cosine. Cosine of 50 degrees equals what divided by what in this triangle on the right? What goes on the top? What goes on the bottom?
Top would be X
Okay.
and then probably 32.
Yes. Okay. So can you solve that for x for us, please?
I got 20.6.
Okay. And you might go out a few more decimal places for an intermediate calculation like that. Um, especially if you're going to reuse it. But yeah, 20.6 is good on that one. So there's a couple of ways to find h now. You could continue to use sine, cosine, and tangent. That's always allowed. Or you can say, okay, let me use Pythagorean theorem because you know two of the three sides in the triangle on the right. You know x, 20.6, you know the hypotenuse. How do you think you would have found h? Would you continue to use trig or would you have used a Pythagorean theorem?
Probably continue to use trig.
Okay. So which trig function will you use now to find h?
So would it be cosine?
You already used
Or
cosine. Yeah, you generally don't reuse it. Um, you could if you use the angle up here, but assume you're just going to use the 50 again.
um would it sine? It'd be sine.
Sine, yeah. Sine 50 equals h over 32. Okay, so could you solve that for
I got 24.5. Yeah.
okay. So h is 24.5. Again, you might go out a few more decimal places if depending on the problem here. So that's really great, but we want x plus y. Like we found h, and you're like, why do we even find h? It's because you need another side of the triangle on the left. And sometimes it's good to just kind of redraw that triangle and say, okay, I'm trying to find y. I know that this is 40. I know that h is 24.5. How can I find y? Well, there's no way to do it with trig right now. Okay, so you have to use Pythagorean theorem.
Yeah.
So I'd like to use Pythagorean theorem to solve for y, please. And that's the a squared plus b squared equals c squared.
So could you do 40 squared equals 24.5 squared plus b squared?
Yes, yes.
I got 31.6.
Okay, that sounds reasonable. So that is, so you said 31.6, that's the Y value. You would add it X to it, and then you would want to use the correct units for your answer.
So when it's asking how far apart are they, would you subtract that from what you got from X?
But no, just asking how far apart are the guide wires. X plus Y is your final answer.
Oh, okay. So then it'd be like 52.2, I think.
Yeah, that sounds right.
Okay.
This is a good question. This one doesn't allow you to sort of do it directly without knowing all the intermediate steps and values.
Right.
So good problem there. All right. Number 9. Okay, a plane is between two observers. One observer is west of the plane with an angle of elevation of 50. The other observer is east of the plane with an angle of elevation of 61. The two observers are 4.213 miles apart. How far is it from the plane to the first observer who is west of the plane? Okay. So good job. I don't know if is this your writing in red or you said it's the answer key?
It's an answer key, so I'm sure it has his what he wrote on it.
Okay,
My teacher.
yeah, I see. It's not very helpful actually the way it's written. It's just like it's too direct.
Okay.
So you have to kind of start a little. You're like, okay, person 1 over here, and then person 2 over there. One observer is west of the plane, so west will be to the left here. Angle of elevation of 50. The other observer east of the plane is 61 degrees. The two observers are 4.213 miles apart. How far is it from the plane to the first observer who is west of the plane? So they're looking for side X. How far is it from the plane is up here to the first observer who is west of the plane? Do you agree with that?
Yes.
Okay. So this is where your assignment transitions from, okay, right angle trigonometry to non-right angle trigonometry. And you're not sure what I mean by that. Like every problem we've done has been a right triangle. Certain things apply. This is a non-right triangle, so there's only a few things that apply, namely law of sines, law of cosines. Do you remember either of those, or if either of those apply here to this problem?
So would you do like? Would you use sine? I think law of sines.
I mean, yeah, I mean, if you're referring to the answer, like, okay, it's law of sines, but let's talk about why. So to use law of sines, you have to have an angle and a side, angle and a side across from the angle. So do you have that? Do you have a side and the angle across from it? Well, you kind of do there because you want to solve it. Do you have a side and the angle across from it? This time, no. But can you determine that angle?
Yeah.
Okay, so that angle can be found by subtracting the other two angles from 180. Right, so we'll call this missing angle P. 180 minus 50 minus 64 is E.
Yeah.
Okay, so could you calculate that for us, please?
I got 66.
I'm sorry. I don't know why I put 64. It's 61. So it ends up being 69.
Oh, yeah,
Sorry, I don't
that's
even
right.
couldn't even begin to tell you that. Okay, so now we can use law of sines because we have, and I call it an angle side pair. You've got that one. And then you can always use the one that you're trying to find as an angle side pair. You've got that one there, which is really important. There's no other way to do this problem without it. So my preference is always to put the thing that you're trying to find in the top left. So since you're trying to find the side in the top left, the sine of the angle across from it goes in the bottom left. So sine of 61. On the other side of the equation, you have to put the side that you have 4.213. It's got a mirror. It's got to be side over angle, sine of 69 degrees.
Right.
All right, so now we have only one variable. We can easily solve this for x by undoing sine 61. So multiplying both sides by the sine of 61, sine of 61, canceling out. So x equals 4.213 sine 61, sine 69. So if you grab a calculator, see what you come up with.
I got 3.95.
Yeah, and then that's in miles because the other one is in miles. That was given. The other thing to think about when you're taking tests is like, you're going to get one of each. Like, okay, I should get one law of sines problem, one law of cosines problem. And you almost want to look for it. So you're like, okay, well, that one's law of sines. The other one's probably law of cosines. So now that we're done with this one, that it did just want the distance over here, x, we know the next one is probably law of cosines.
Yeah.
And it's reasonable to assume that, unless you know that the instructor's a really difficult person. Because I would just tell you, say, hey, you're gonna have one law of sines, one law of cosines, and I'm gonna go take a look here. All right, a boat racer takes off on a 3-sided course. He travels due east for 20 kilometers, then turns north and west and goes 13 kilometers. Finally, she heads back to this finish line for 11 kilometers. What are the angles at the 3 turns? Okay, so the drawing here, you gotta have some sort of starting point. It's you kind of gotta look backwards. Okay, east and then north and west and then back to the finish line. So 20 miles due east. North and west would actually be more like this, and then back like that. But it may not actually work with the sides, like when we get the angle. I guess it's okay. So you don't have to draw it to scale. You just have to sort of say, okay, I'm starting, and I'm going to use the same letters the instructor uses in case you want to look at that solution later. So it's not too odd, but you start at 20, 13, and 11. So because you're given side, 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 or side, angle, side, that is why it's law of cosines. You have to be able to distinguish between the two types.
Yeah.
Right. So the idea is you got to find all three angles. It doesn't matter which one you find. We're going to find, I guess, angle C first, because typically the law of sines formula, like the first one you see is written this way, like this,
Yeah.
or it's written in such a way where it's already solved for cosine of the angle. Just depends on your textbook. Could be a
Right.
bit overwhelming to have the three formulas for the side, three formulas for the angle. All right. So for the next part of this, it's about putting numbers in. So this is little c, this is little b, this is little a. Sometimes that's helpful to do. So we've got 13 squared equals 11 squared plus 20 squared minus 2 times 11 times 20, cosine of the angle that we don't know. So how comfortable are you at this point to solve for the angle? Do you feel like you can solve this for angle C, or do you feel like that you need a few more steps here of the work?
Um, well, for angles, so wouldn't we would need angles C to for cosine of C, right?
Do that one more time.
Like we would need the angle to be plugged in for cosine of C.
We're using this formula to find the angle. So it's the only unknown. So the like in the other version of law of cosines, you are given the angle. Here you're not given the angle. So you have to like move the 11 squared over, move the 20 squared over, divide by this number, and then take the inverse cosine.
Right.
And I'm happy to show that. I just kind of wanted to see where you're at on with that.
Yeah. I think for finding like angles, I would use the formula like
Where it's
cosine of
already solved. Okay, you would already use the formula for that. Cosine C squared minus A squared
yeah.
minus B squared. That's fine. And
Or
that's what
I think it's A squared plus B squared.
okay. So your book moves this negative up top. That's fine. So I don't try to pretend like I know what the formula is going to be in your book, because they're all different.
Yeah.
And so then C is the cosine inverse of this. Okay, so you just have to put the numbers in like we were doing 11 squared plus 20 squared minus 13 squared. 2 times 20 times 13.
Yeah.
And it should be reasonable, I mean, it should be like a number between 0 and 180. So that's kind of your reasonableness check. It's like, well, does it actually make sense? Kind of, sort of,
Right. My calculator's being weird. It's like, okay, let me try this again.
So in terms of how you do this in the calculator, you need parentheses in the numerator and parentheses in the denominator.
Yeah. I feel like I did that and then it keeps saying error. Okay, let me try it. Let me try it one more time.
I'll be happy to grab my calculator here and share screens on that if needed.
Oh wait, I think I might have got it. I got 47.4.
That sounds like what I've got here. Yes, 47.4. Very good. Okay. Now, unfortunately, unfortunately, we have to do something else here. And you can either use law of cosines to find the other angle or law of sines. Actually, I put that in the wrong spot. That's that one there. So how do you think you would do it? Would you go back to law of sines, or would you say, okay, I'm going to just use law of cosines again to find, like, for example, A?
I think I would probably use law of sines.
Okay. So I'm going to do is just re-grab this because I got a lot of stuff going on the screen here. So let's find angle B, for example. So we'll go sine big B over little b equals sine big C over little c. Okay. And big B is the angle, okay, which we're trying to find, but little b is the side length over little c 13.
Yeah.
So just a matter of getting that all in to the right place in the equation. So we can clear out the 20 on the bottom on the left by multiplying both sides by 20. Sine big B equals 20 over 13 sine 47.4. Right.
So
And
I
then,
got, oh,
there's more to do here because you haven't solved for B. You've only solved for sine B. So to solve
right.
for B, you have to take the sine inverse of whatever number you just got.
So I got 1.13 before I did the sine inverse, but then whenever I plug that in, it says
Yeah,
error.
yeah, I would agree. So I feel like there must have been a mistake on this one here. C is, oh, so there was a mistake down here. This should have been AB on the bottom. That's why this angle is wrong. So this is 11 and 20. So this angle is wrong here. That's why we're running into issues. So let me recalculate that real quick. So it ends up being 36.9. And then that changes this down here to 36.9. $36.9. Yeah, I agree. It does give you a number that is undefined. So hopefully this one works out. This one does.
I got 67.5.
Yes. So B is 67.5. And you want to recognize, okay, I have two of the three sides of the triangle. What's it going to take for me to find the third? Well, I could do anything. I could use law of sines, law of cosines. Can also just say, well, it's 180 minus the other two angles.
Right.
But the other angle, 180 minus 67.5 minus 47.4.
Yeah, I got 65.1.
Our answers, though, are very different than what they have.
Really?
This is not good. So I feel like it all came back from this, trying to use this formula here that I don't know why it wouldn't be right.
Oh yeah, now I'm going MST. Well, because he did cosine of A. He found the angle of A. And he did,
That's
yeah.
the angle. We labeled this the same, and that's angle A. We got that same angle.
And then right after that he found angle B, and then he just added them up.
Yeah. Oh, I draw. Okay, well now I see the issue. I've drawn the triangle I made is very different than. That's why this is all wrong. So the what we did is correct for this triangle up here. That's not the triangle he should. So he starts out. So he goes due east. That's the 20, 13, and then the 11. Okay, so that does make more sense now. So to find cosine of A, it is 11 squared plus 20 squared minus 13 squared over 2 times 11 times 20. So this ends up producing the 36.9 degree. And then to find C, we can do C next. So to find sine C over 11 equals sine 36.9 over 13. And that will produce angle C of 30.51. Okay. And then you can find the missing. So I misread this. I guess I thought it was going west. You're really going east. That's
Yeah.
the path. So that's the reason for the difference there in this.
Okay.
All right. Do you need to do any of this Huron's formula?
No, that's we kind of took notes on that, and there was maybe one question on the quiz about that. He said not to really focus on it.
Okay.
But yeah, I assumed that the lesson was going to be a little shorter today, just because well, we're going to get all of our reviews this upcoming week, so then I'll have a bunch of stuff to work on Sunday.
Sure. Yeah. And if you need to add some lessons, just let me know, or of course, so you can go to the website and book them as well. But kind of here, you want to stop here, and that's okay with me. Go and stop the recording.